Dear students, today in this module we will be discussing about e-waste. Now what are e-waste? E-waste are nothing but electronic waste or waste electrical and electronic equipment. Now it is a type of solid waste and they require special care or attention in terms of its management, because they create a lot of environmental and health hazards. Now the e-waste generation has been increasing with time because many people have started using computers, mobiles, refrigerators. Now every individual house has all these electronic items. Now examples of electronic waste are the electronic gadgets, mobiles, personal computers, then your refrigerators and so on. Now e-waste contains a lot of heavy metals like gold, lead, silver, copper, which can be recovered and reused. So a separate industry works on e-waste management to recover these metals. Now we will look into further details in the upcoming slides. Now with this introduction, now let us discuss about the learning objectives of this module. The learning objectives of this module would be to understand what is e-waste, what are its sources of generation, the challenges that we face in e-waste generation and management both in developing and developed countries. Then we will discuss about the classification of e-waste and e-waste management aspect with special emphasis on e-waste management in India. We will also discuss about various steps that are involved in e-waste management. Now, as I told you earlier, e-waste is nothing but electronic waste or waste electrical and electronic equipment. It is also called as end of life electronics. They are electronic devices which are no longer of any use to the owner. Now, examples again I have mentioned earlier: refrigerators, air conditioners, cell phones, personal systems, consumer electronics and so on. Now e-waste in India are categorized into two groups based on their usage as 1. Information technology and telecommunication equipment, 2. Consumer electrical and electronic goods. Now information technology and telecommunication, it is very clear, all your mobile phones comes under this, mobile phones, computers, laptops, all these things comes under information technology and telecommunication equipment. Consumer electrical and electronics includes your refrigerators, televisions and motherboards which are associated with these electronic goods. Now in general, e-waste is divided into 5 groups based on the material that is used. 1. Ferrous metals, non-ferrous metals, glass, plastic and others. If you see the composition of the electronic waste, iron and steel occupies a major proportion of 48%, followed by plastic which contributes to 21% of your weight, and then followed by your non-ferrous metals. Now this also includes precious metals. Now this contributes to total 13% of weight, and out of the 13%, 7% is occupied by copper. Now this figure shows what the typical material fractions in a waste electrical and electronic equipment. Now as I told you earlier, this composition is given in terms of weight. Iron and steel occupies maximum 47.9%, followed by plastic 15.3%, copper 7%, glass 5.4%, flame retarded plastic is 5.3%, aluminum 4.7%, the printed circuit boards 3.1% and others 4.6%. Wood, plywood is around 2.6%, concrete and ceramics about 2%, and other metals like non-ferrous metals occupy 1%. The least amount is occupied by rubber, which contributes to 0.9% by composition in the waste electrical and electronic equipment. Now if you look into the environmental concerns that is related to e-waste management, or why is e-waste management essential? Because in the introduction I told you they contribute or they create a lot of health and environmental hazard. For example, if you see, e-waste contains a lot of metals, as I told you earlier, like it contains lead, gold, cadmium, boron, beryllium, so on. Lead is used in circuit boards and CRTs. CRTs are nothing but cathode ray tubes. Then cadmium is used in contacts and switches. Bromated flame retardants are used in plastics. Now, these heavy metals, when disposed of without any treatment, they slowly enter into the soil, and through soil it also enters into the food chain and affects the health of an individual. Even animals' health are also affected. Now, air pollution aspect as such, if you see, when you burn this waste, they generate a lot of gases which might lead to air pollution. It also results in the acidification of soil, because these e-waste contains acids and heavy metals along with other substances, which when mixes with water, it increases or it releases acids, which when enters into the soil matrix, it acidifies the medium and increases the acid content of the soil. Now, this table explains in detail what are the different health effects that are caused by the e-waste toxins. For example, the printed circuit boards which contains lead and cadmium affects the nervous system, kidney and liver. Motherboards which contain beryllium, it affects your lungs and skin. Cathode ray tubes which contains lead oxide, barium and cadmium, it affects your heart, liver and other muscles. Switches and flat screen monitors contains mercury, it affects your brain and skin. Computer batteries which contain cadmium, again it affects your liver and kidney. Capacitors and transformers which contain PCBs, the polychlorinated biphenyls, they affect your overall immune system. Printed circuit boards, plastics which contain brominated flame retardant, again it affects your nervous system and the overall immune of your body. The cable insulation and coating which contains polyvinyl chloride, again it affects your immune system. Now, the plastic housing which contains bromine, it affects the endocrine system, the endocrine glands in your body. Now, this table summarizes the top 10 states where e-waste generation is very high. So, among this, Maharashtra tops, followed by Tamil Nadu, Andhra Pradesh, Uttar Pradesh, West Bengal, Delhi, Karnataka, Gujarat, Madhya Pradesh and Punjab. Now, let us discuss about the challenges that are associated with e-waste management. Irrespective whether it is a developed country or underdeveloped country or developing countries, commonly there are certain challenges. Now, as you see, these e-waste contains around 60% of recyclables. So, generally they facilitate trade between developed and developing countries. That means the developed countries send their waste to developing countries, and developing countries generate revenue by collecting this 60% of recyclables from the e-waste. Now, since they contain a lot of toxic and valuable metals, it is difficult to manage e-waste. Now, in developing countries, the cost of repair of these electronic items are very high when compared to the cost of actual electronic item. So, what people do is, rather than spending so much in repairing an item, they go and purchase a new one. So, as a result, the e-waste generation increases. Then here recycling is also expensive. Then the land availability in landfills are very less. So, as a result, the e-waste management plan encourages for you to find out alternate methods for management. Again, this is one important or major challenge. Now, improper methods of dismantling the electronic items by unskilled workers are also a major challenge which we face in recent times. Generally, what do people do is, like these unskilled workers, like if you see uneducated people or unskilled workers for dismantling these electronic items and recover these metals. This results in the occupational hazard as well as improper dismantling, where the quality of the material is also lost. That is again a big challenge. Lack of proper regulation also becomes a great challenge for the e-waste management. Now, let us specifically discuss about the challenges that developed countries face in e-waste management. Now, here the increasing quantity of e-waste in developed countries is like, as I told you earlier, the cost of repair is very high and the cost of equipment is very low. So, rather than repairing it, people tend to buy a new one. So, this keeps on adding e-waste in the developed countries. Second, if you see the quantity of e-waste generated ends up in landfills because it is not being repaired. Then the regulations were framed by local government bodies to manage e-waste due to decreased availability of landfill space and increased recognition of the toxic nature of e-waste. Now, this is again a challenge which we already discussed earlier. Here the developed countries frame regulations to find out new or alternate methods because there is less availability of land in landfill space. Also, these e-waste contains a lot of toxic materials, so you need certain alternative methods for its safe disposal. Now, the regulations has made it expensive to recycle e-waste also. So, that is again another challenge due to which e-waste gets accumulated. So, all these points necessitate the formulation or framing out of new alternate technology so that e-waste management can be cheaper and more efficient. Now, what are the challenges that developing countries face? When you talk about developing countries, the increasing quantity of e-waste is not only due to economic growth, but also the challenge or related change in consumer behavior. Now, e-waste is considered as a resource for income generation instead of waste owing to its availability of large scale unskilled labor. Since you have these developing countries have a lot of population who are unskilled as well as unemployed. So, they involve these people in dismantling or segregation or resource recovery from the e-waste. Again, mostly informal sector or unskilled persons are involved in dismantling and resource recovery. So, this is again becomes a bigger challenge in e-waste management in developing countries. They use unsound environmental practices, again that becomes a challenge in developing countries. Also, lack of proper regulation leads to this challenge. Now, let us discuss about the sources of e-waste. Now, from where the e-waste are actually generated. Electrical and electronic equipment include a large gamut of products, starting from your small household equipment to large household equipment. Small household equipments like toys and large household equipments like refrigerators, washing machines, then mobiles. Then comes your IT sector where office equipments are generated, disks, CDs, floppies, pen drives, broken hard disks, CPUs, monitors and so on. Then the fourth one is your hospital sector where your medical equipments are generated. And the last one is institutional sector, again institutes like universities, schools, colleges where computers, laptops, floppies, pen drives, hard disks are generated. Sources of e-waste generation are very large and it ranges from individual users to households to organizations. Now, let us discuss about the classification of e-waste. There is no specific or a generic system of classification of e-waste and it varies from country to country. The United Nations University Classification, also known as UNU keys, classifies e-waste based on certain categories. 1. Based on products of similar function. 2. Comparable material composition, that is in terms of hazardous substance and valuable materials. 3rd, average weight, end of life characteristics, lifespan distribution. According to this, it has almost 54 categories of e-waste that are grouped under 10 primary categories. Now, this table provides you how e-waste is categorized in India. According to Ministry of Environment, Forest and Climate Change, they have categorized e-waste into 2 groups. 1. Information technology and telecommunication equipment, and 2. Consumer electrical and electronic items. Now, under information technology, centralized data processing, mainframes, mini computers, personal computers including your CPU, laptops, notebook, notepad, printers including your cartridges, copying equipment, electrical and electronic typewriters, telex, telephones all come under information technology and telecommunication equipment. Now, as I told you earlier, consumer electrical and electronic goods include your television sets, including your LCD, LED, refrigerators, washing machines, air conditioners and centralized air conditioning plants. Dear students, welcome back. In the first part, we discussed about what is e-waste. Now, what are the different sources from e-waste is generated. Then we discussed about the classification, where the UNU, how it is classifying e-waste, and in India, how e-waste is categorized into two main categories like information technology and consumer electrical and electronic goods. Now, in the second part, we will discuss about the management of e-waste. Now, e-waste management is based on the principle of extended producer responsibility. In short, you call it as EPR. Now, EPR is defined as an environmental protection strategy that makes a manufacturer of the product responsible for the entire life cycle of the product and especially for the take back, recycling and final disposal of the product. So, if a company is having an EPR, for example, let us take any company for that matter, if you are buying a laptop, that company, like for example, if you are buying a Dell laptop. Now, the Dell company is responsible till the life cycle of the product. They should take back, recycle and they will be in charge till the final disposal of the product. That is EPR. Now, there are 5 parameters that are to be considered while designing an EPR based on e-waste management system. Now, they include legal regulation, system coverage, system financing, producer responsibility and compliance. These are the 5 parameters which you have to look into while designing your EPR. Now, these above mentioned parameters are closely interlinked and they play a very important role in a proper management of these waste electrical and electronic equipments. The linking of the manufacturing phase of the product with its disposal by the EPR generally encourages the manufacturer to go for better product design and also enable easy upgrading and recycling. So, by doing so, the life of the product is increased and also the e-waste generation will be minimized. The Swiss RD, where the return, taking back and disposal of electrical and electronic equipment promotes collection, recycling of e-waste and it also restricts the use of certain hazardous substances in your electrical and electronic equipment. Many countries in Asia like Japan, South Korea, Taiwan also have their own national regulations to tackle the challenges of e-waste. In developing countries, lack of regulation is a very serious problem which we have already discussed in the challenges of e-waste. Now, many developing countries like China and India have recently implemented e-waste legislation in line with the European Union Electrical and Electronic Equipment Directive. In short, it is abbreviated as EUWEEE. Now, generally in developing countries there is a big problem. What do they do is they involve a lot of unskilled workers for recovering resource from this e-waste. Now, when they recover or by dismantling the e-waste, they are exposed to a lot of health hazards. Generally, they are considered as environmentally unsound practice because the segregation or dismantling generally occurs in the backyard and they do not follow proper procedures. These informal sector generally generate a lot of revenue and that becomes a source of living for these unskilled workers. Again, this we have already discussed as one of the major challenges of the developing countries. Now, let us discuss about the major components of e-waste management. One is e-waste collection, sorting and disposal. The other one is e-waste recycling. Now, again, just like municipal solid waste or any other solid waste, e-waste also has a waste management steps which involves collection, sorting where it is segregated and treated before disposal. And recycling, it becomes a part of a waste processing or treatment step. In industries, e-waste is managed using the principle of waste minimization. Now, there are various steps that are involved in waste minimization. One is inventory management, second is your production or process modification, third volume reduction and fourth recovery and reuse. Now, waste minimization generally talks about modifications in your process or any particular step where you can minimize the waste by either replacing with any alternative method that can reduce the waste minimization, or you can use any other less hazardous substance like that is spoken up in your production or process modification. Then you can reduce the volume of waste generation by adopting alternate methods, and whatever waste that is generated you can recover or reuse. This is the principle of waste minimization. Even that can be applied to e-waste, and generally, as I told you earlier, industries use this waste minimization plan. Now, let us discuss about e-waste treatment. E-waste is a mixture of valuable materials as well as toxic substances. Now, valuable materials should be recovered and recycled, and toxic materials should be treated before disposal. Now, e-waste generally requires a labor intensive manual segregation along with capital intensive technical process for the separation of toxic waste. Now, handling e-waste by manual dismantling has been suggested as a best starting process for e-waste treatment. Now, the dismantled e-waste will then be separated into glass, copper, steel, aluminum, plastic and other printed circuit boards. The total content of printed circuit board in e-waste is generally 3 to 5% of weight, while metals, plastic and glass constitute 95 to 97%. Now, the hazardous components like the capacitors, CRT screens, CFC gases, light bulbs, batteries are generally separated and removed at this particular stage. Then they are mechanically processed, which is a large scale operation, and it enables increase of recyclable materials in a dedicated fraction. It also helps to further separate hazardous materials. Now, the typical components of a mechanical processing units include your crushing units, shredders, magnetic eddy current separator and air separators. Now, what happens is the material that comes in are crushed using certain shredders or crushing units. Shredders will reduce the size into small, and crushing units will generally reduce the larger item into lesser ones, and further shredders are applied to reduce the size further. Now, magnetic and eddy current separators, what do they do is you apply magnetic field and all the ferrous metals are separated in a magnetic separator, and in eddy current separator non-ferrous metals like aluminum and copper will be separated. Now, air separators are used for separation of lighter materials. For example, if you have less weight or less density material, if you use air separators like air classifier, then they can be separated easily. The gas emissions are filtered and the effluents that are treated to minimize the environmental impact. The final step in e-waste management is e-waste recycling, and it is also called as refining. Now, here there are some photographs of the crushers and shredding units. On the left side you can see crushing units. The enlarged image is on the right side, where if you add them, they have a big jaw so that it will crush the item into smaller fractions. In the second image you can see these are magnetic and eddy current separators. You can see a pulley sort of arrangement where the material is coming through a conveyor belt, and this pulley will have a magnetic field. It will attach, and once the pulley turns over, all the substance will be separated, like your non-metallic will be separated and non-ferrous metals will be separated. Now, during the treatment process, whatever fractions of waste that are obtained are refined, and they are generally sold as a secondary raw material. Now, during the refining process, attention is paid to metals, glass and plastic. At the end of refining and after extraction of valuable fraction, the residue, which is usually non-usable and toxic, is disposed of, and the rest which is usable are either sent as a secondary raw material or it is recycled back. Now, here I have given a flow chart which shows how a scrap IC board is treated. Now, generally the IC board or the integrated circuit boards, they are subjected to primary crushers. Once they are crushed into smaller size, then they are subjected to magnetic separator. As I told you earlier, magnetic separator, it helps in separation of metallic items. Like for example, if you have iron in them, when you apply magnet, obviously it will stick to it, and once you stop the magnetic field, you can separate the iron or any other metallic component. Then they are further subjected to hammer mills. Hammer mills are again a sort of size reduction units, where it consists of a drum like item, where you have 3 or 4 hammers. When your waste is subjected, the hammers keep hitting at the waste and it will reduce the size further. Now, once the size is reduced further, you subject it to a cyclone separator. Now, cyclone separator is a device where it separates all the dust materials which are associated or which is released during the process. Now, after this, once again they are separated to magnetic separator to separate iron and non-ferrous substances. Further, once again after this separation, they will be subjected to an air classifier where light plastics will be removed. Once again after this air classifier, they will be subjected to eddy current separator to separate out aluminum and other non-ferrous metals like copper. Finally, they will separate it to electrostatic separator, where copper will be removed and whatever that is left out, that is the fiberglass or resin, will be further disposed of, or it can be used as a raw material. Now, another example in e-waste treatment or management, you can say, it is CRT tube recycling. Now, CRT, as I told you earlier, these are cathode ray tubes which are generally used in televisions and computer monitors. Now, they consist of glass of different composition. The front panel is made of lead free barium strontium glass, whereas the inner side or the funnel hidden side consists of glass with lead oxides. Now, the glass recovered from CRT can be used in further manufacturing of CRTs, like it is called as closed loop recycling, where the materials that is recovered from the waste product, it is used in the manufacturing of the same product or into other products like open loop recycling. Now, recycling of the waste CRTs generally consists of 2 broad technologies. One is your glass to glass and the other one is glass to lead recycling. Now, first let us discuss about glass to glass recycling. Now, glass to glass recycling, as I told you, it is a closed loop process where the CRTs that are recovered from the waste are sent to CRT manufacturing to obtain leaded and unleaded glass required for the manufacturing of new CRTs. Now, the steps that are involved during this process include: 1. Remove the CRT from the plastic casing, then release the vacuum in the tube. Third, remove various metals and non-glass metals including the electronic gun, then separate panel glass from funnel glass, and lastly remove the phosphor coating from the panel glass. Now, the advantages of a glass to glass recycling is it enables replacement of virgin material with recycled glass at lower cost. Also, it improves the quality of output glass. Now, there are also disadvantages. The difficulty of identifying glass composition in the waste CRT is little difficult. Also, it involves high cost of collection and significant labor. Now, the second type is your glass to lead recycling. In glass to lead recycling, it involves separating and recovery of metallic lead and copper from waste CRT glass using a smelting process. The recovered CRT glass then goes into lead smelters and acts like a fluxing agent during the smelting process. The process is automated, and when compared to glass recycling, they are more cost effective. The process also safeguards workers from inhaling lead that is generated during the process. Now, let us discuss about the e-waste management in India. Now, according to UN report, India is the 5th biggest producer of e-waste in the world, discarding around 1.7 million tons of electronic and electrical equipment. The e-waste stream in the country, it is increasing at a very faster rate, and it is 3 times faster than the municipal waste stream generation. Government institution, public and private sectors have been identified as major contributors, and they contribute to around 70% of the total amount. Now, e-waste management in India has been largely left to highly organized informal sector, which generally performs the collection, segregation and dismantling and final recycling process. The informal sector, as I told you earlier, they are generally engaged in waste recycling companies, and they generally comprise of urban poor and rural migrants. They handle or recycle nearly 95% of the total waste that is recycled. The recycling of this informal sector is done in a primitive way in the backyard of businesses, and hence they are exposed to more health hazards. Also, improper or unsound environmental practices generally damages the environment and also leads to a lot of loss of valuable material due to unsound dismantling practices. Now, there are reports on environmental and toxicological impacts of improper treatment of e-waste, but when you talk about impact on recycling workers who handle or dismantle the waste, it is not available. Now, since the informal recycling happens in slums and outskirts, mostly the workers who are involved are children, and they generally get affected to respiratory problems. Delhi is one example which is considered or recognized as a major hub for informal recycling in the country. The informal sector in Delhi alone employs around 25,000 people in this sector. Now, let us discuss about the e-waste regulation in India. E-waste is regarded as a hazardous waste, mostly due to the presence of hazardous substances in them, because they cause serious environmental and health effects. So, to avoid these environmental effects and health effects, you have to manage them properly. Although a separate rule has been framed to manage hazardous waste in India, still a separate rule was enacted in 2012 called as Ewaste Management and Handling Rules 2011 due to its unique nature. These rules have further been amended taking into consideration the existing e-waste management plan, and they have been reenacted as Ewaste Management Rules 2016, which came into force in October 2016. Now, let us see what are the salient features of this e-waste management rule. Now, it is based on the principle of EPR, where the producer of the equipment has been mandated to channelize the e-waste generated after the use of their equipment and manage them in an environmentally sound manner. The producer can do this by implementing a take-back system or setting up of collection centers for, or both by having agreements with authorized dismantler or recycler. They could do either individually or collectively through a producer responsibility organization. I mean, Dell, for example, if you take, Dell can do it separately, or Dell 2-3 companies together, they can have a collective effort which is called as producer responsibility organization. Now, it recognizes and defines each of the stakeholder who are involved with production of electronic equipment and management of the waste generated at the end of its useful life, namely the producer, manufacturer, consumer, bulk consumer, collection centers, dealers, e-tailers, refurbisher, dismantler and recycler. The responsibility of each of the stakeholders are explicitly given in the rules. Specific targets have also been set, especially for the producers, with an expectation of managing around 30% of waste that is generated during the first 2 years of implementation of the rule. The target will increase gradually, so that by the 7th year the implementation of the rule should achieve nearly 70% of e-waste generated in the country. Now, the penalty of non-compliance of meeting the target includes cancellation of EPR authorization, which would result in the producer not being able to put products in the market until EPR authorization is granted. Apart from having a planned system for managing e-waste, the producers are also required to reduce the amount of hazardous substance in their equipment. The equipment should not contain lead, mercury, chromium and PCBs beyond a certain concentration value of 0.1% by weight, and cadmium should be not above 0.01% in any homogeneous material. To summarize, at the end of this module, we have defined what is e-waste. Then we looked into various challenges that is involved in e-waste management in developed and developing countries. Then we discussed about the various sources from where e-waste is generally generated, and we saw that it is not it is a large sector. It starts from individual, household as well as institutional generation. Then we saw classification of e-waste, where U and U keys have classified e-waste into 5 broad categories. With respect to India, MOEFCC in 2016, they have classified e-waste into 2 broad categories. One is information technology and the other one is consumer electronic goods. Then we discussed about e-waste management. We saw how e-waste should be managed properly. Then we started discussing about e-waste treatment, where I gave you 2 examples. One, CRT tubes, how CRT tubes are recycled, and another one, how an IC scrap board can be processed and segregated accordingly. Then lastly, we discussed about e-waste management in India, how these unorganized or unskilled sectors or the laborers, especially children, are involved in dismantling of these electronic goods, and by doing so how the quality of the material is lost and how these valuable materials are lost, and what are the different hazards they are exposed to, and due to these unsound practices how the environment is getting contaminated. Then lastly, we discussed about the e-waste management rules, and I have also told about certain salient features of this rule, where we discussed about the EPR, how a company either individually or collectively should form or follow this EPR, and what are the penalties or that will be provided if they do not comply. And then we also saw how or when these rules were framed. I hope you would have enjoyed this module. Thank you.